Hello, dear students. Welcome to your online science classes. In our first lesson, we will revise Unit 4. I know before the lockdown we finished Unit 4, and I'm aware that Ms. Sama made you 4 online lessons on the last chapters, but I thought it would be a good idea to revise the entire unit one last time before moving on to a new lesson. As we all know, this unit talks about sound. What I will be doing in this lesson is to go through each chapter, explain the words you need to know, show you experiments on the subject, and then summarize the chapter with the most important points. We will start with chapter 1 and 2 together. Sound travels through material and sound travels through different materials. The pages of these chapters are from 52 to 55 in your Cambridge Primary Science book. So please open your books on page 52 to start. The words we need to know in this chapter are source and travel. Let me see if you remember the definition of these words. Please pause the video, try to write the definition for these two words, and then resume to see the answers. Welcome back to the video. Now let's look at the definition. Source is where the sound comes from, and travel is moving from one place to another. Now, the first thing we need to know about sounds is they come from sources. They all have a source. For example, the door was a source, the bell, the guitar, the hammer here. These keynotes were all sources of the sound we hear. The second thing is sounds travel. We hear sounds because they travel from the source to our ears. The third thing is we should know that sounds travel through materials. How did you hear the sound of the door or the bell? How are you able to hear my voice now? You're able to hear my voice because the sound traveled from the source through the air, which is the material, to your ears. Sound can travel through different types of material. Now, to investigate this, we need to go back to the book on page 54. We did this experiment in class where we got the wood, we got the balloon of water and the clock, and we tested out how sound travels through different types of material. We found out that sound can travel through all the three states of matter. By the way, different types of material means states of matter. We found out that sound can travel through all the three states of matter, air, water, wood. We were still able to hear the sound. But sound can travel through some types of material much better than the rest. Sound can travel through solid the best. Why? Because the particles in solid are very, very tight together, as you can see. So when one particle vibrates, the rest of the particles vibrate almost immediately. So sound can travel much faster through solid than any other states of matter. To prove that, let's watch this video.
If you don't believe that air vibrates, take a look at this. Sound waves can travel through solid things like wood as well. The particles in a solid are packed together far more tightly than air particles. What difference do you think this makes to the sounds you hear? Listening with a stethoscope can hurt. Does sound travel faster in the ground or through the air? And is the speed of sound ever as fast as the speed of light? To find out, you need to make a sound that can travel a long distance. 5 tons of plastic explosive should do the trick. How would you detect sound waves in the ground? Samantha's going to watch for the explosion, but she's wearing headphones so she can't hear it. Fung is going to listen for it, so he's wearing a blindfold. And Elizabeth's going to detect sound waves in the ground.
Ready?
So here we have 3 students. This experiment is to test out speed of sound and the speed of light, and then the speed of sound in the air and in solid, in the ground. Now, this girl cannot feel or hear anything. She only sees the explosion. And this guy, he cannot see anything and he is not feeling anything as well. He can just hear the explosion. And this girl over here, she cannot see or hear. She should feel the explosion of the sound, the vibration of the sound through the ground.
Ready? Okay.
So, who's going to be the first, second and third to detect the explosion? They were waiting to see the light, hear the sound, or feel the sound. Samantha was first because the light got to them before the sound. Elizabeth was next when she felt the sound coming through the ground. And Fung was last when he heard the sound of the explosion coming through the air. The speed of sound in the air is 350 meters per second. At 5,000 meters per second, sound travels much faster through the ground. But light is much faster than any sound, at 300 million meters per second.
Okay, so we can see that light is much faster than sound. But our focus here is between the speed of sound in the air and the speed of sound in the ground, in the solid. As we can see that sound travels much faster in solid, in the ground, than the air. Again, because the particles in the solid are very packed together. So even one of them moves, the rest are moving very quickly, very fast. Sound can travel through different type of material. The second state of matter we're talking about is liquid. Again, sound can travel through liquid but not as fast as solid, because the particles in liquid are not as tightly packed together. They are close together, yes, but they still have room to roam around and slide on each other. So the vibration is still quick, but not as fast and quick as it happens in the particles in the solid. Let's watch this video.
Are going to whack this as hard as we can, maybe even a little harder. Yeah, and we're going in the water, and there you see the molecules quickly jump from one to the next. Let's do it again. And we're going in, and we see those molecules just really bump into each other and spread in a wave-like fashion. It goes really fast. If we could put it in slow motion, I think it would be beautiful, but there we see it again. And we see a visualization of the sound waves.
As we saw in the video that the sound can travel through liquid, we saw the water moving and the particles of water moving and vibrating, but it's not as fast as solid. I also did a small experiment to test out how sound travels between solid and liquid.
This experiment shows the difference between sound traveling in liquid and sound traveling in solid. Now we have the desk as solid and we have this bucket of water as liquid. To test out how sound travels differently between them, I'm gonna drop this sponge material type of thing onto the solid. We're gonna see what kind of sound it makes, and then I'm gonna drop the same material from the same distance into the bucket of water here. To make this a fair test, we need to have the same distance and the same material for both solid and the water here. As we saw, the sponge, when it hit the solid, it made a bigger sound because the particles in solids are close together, so the sound travels faster between them.
For gas, because the particles are not as close together as they are in solid and liquid, sound doesn't travel as fast in the air, because it takes longer until the particles hit each other and the vibration travels. To test this out, go to your desk or any table in the house really, knock on the desk just like this picture, the first picture we have here. So you knock on the desk and see how is the sound. And just like this picture, for the second time you put your ear on the desk and knock again. See which sound is stronger. Now, to make this a fair test, you need to use the same power of your knock both for the first and the second picture, so the sound has the same volume and you see which one is really stronger using the same volume. Now let's think about this question. Why do you think outer space is completely silent? Now we know there is no air in the space, and we already know that sound travels through material. We can only hear sound because it travels through material. In our case, it travels through air. Since outer space doesn't have any air, sound cannot travel. And when a place doesn't have any air, it's called a vacuum. So sound cannot travel through a vacuum. That's why outer space is completely silent. The most important points in these two chapters are: sounds come from sources. We can hear sound because it travels through materials from the source to our ear. Sound can travel through different types of material, meaning different states of matter. Sounds travel best through solids. Sound cannot travel through a vacuum. So the next chapter we are covering is chapter 3, How Sound Travels. The pages of this chapter are from page 56 to 57. So please get your book ready on page 56. The words to learn are vibrate and vibration. Vibrate is to shake something very quickly back and forth. Vibration, a very small movement back and forth, or backwards and forwards. Now, vibrate is a verb and vibration is a noun.
Different ways of making sound have one thing in common. They're produced by vibrations, and you can feel these when you put your finger against your throat. As I pull the bow across the string, the bow makes the string vibrate backwards and forwards very quickly. By using a strobe light, we can see the individual vibrations more clearly. All musical instruments need something to vibrate to make the sound. This loud sound is caused by my lips vibrating. This is a more unusual way to cause vibrations. Rubbing my hands on the handles causes the bowl to vibrate, and it makes a sound. But look what's happening inside.
When I hit this drum gently, the vibration is very small. The polystyrene balls only just move, and the sound is quiet. The loudness of a sound depends on the size of the vibrations that made it. The size of a vibration is called its amplitude. The bigger the amplitude, the louder the sound.
The easiest way to feel vibration is to gently place your hand on your throat and say, ah. You can feel the vibration on your fingers. To actually see the vibration is through this experiment. We did this experiment in class, but I'm going to show you again in 2 different videos. As we can see, the grains of rice are moving back and forth when the pencil hits the jar. And for this experiment, we are banging on a tin near the jar. We are not even touching the jar, and we can see the rice moving. The focus points for this chapter are vibration makes sound, sound travels because of vibration, vibration move from the vibrating object, which is the source, through materials to our ears. We are halfway through the unit, and our next chapters are 4.4 loud and soft sounds and 4.5 sound volumes. The pages of these chapters are from 58 to 61. The words you need to learn in these chapters are loud, soft, volume, decibel, sound level meter. Pause the video and write the definition of these words if you remember. We'll come back to the video. Let's look at the definitions. Loud, a sound with big vibrations like an alarm. Soft, a sound with a small vibration like whisper. Volume, how loud or soft a sound is. Decibel, a unit for measuring the volume of a sound. Sound level meter, a machine to measure how loud a sound is.
Today, I would like to explain volume. Sounds are... Excuse me, could Could you keep the noise down, please? I'm trying to do an important talk.
Well, yeah, all right, mate, but I've got to get this fixed, you know what I mean?
Sounds are, of course, vibrations that travel through the air. But what the... I'm sorry about this. That's better. Where was I? Ah, yes. What makes the difference between a quiet sound and a loud sound? Well, it's all to do with the strength of the vibration. A weak vibration makes a gentle sound wave which doesn't travel very far. Be quiet! A vibration with lots of energy makes a very powerful wave.
From what we saw in the video, sounds can be loud and soft. Loud sounds have big vibration and soft sounds have small vibration. Soft sounds like my voice to you right now. And loud sounds just like the drill and when the guy shouted. That was a loud sound. We use this electronic device, the sound level meter, to measure the volume of the sound. Let's watch this video.
Look at this clock. When the bell rings, we can see it as well as hear it. We're close to it, so the sound is quite loud. We can hear the sound the bell makes all the way around the clock. But as we move further away from the clock, the sound of the alarm gets quieter. So how far away we are from a sound will affect how loud it seems to us.
So the volume of the sound to our ears change according to our distance from the source. The further away we are from the source, the softer the sound it gets. To test this out, I prepared a little fun activity for you. Bring a source of a sound like an alarm or a phone, one of them. First, put it next to your ears and see how loud the sound is. Next, put it across the room, put it somewhere across the room and then listen to it again. Then, put it in one room and go to the next room and then listen to the sound. To make this a fair test, use the same sound volume for all the steps, and then test out how loud was the sound in each step. The most important points in these two units are loud sounds have big, strong vibrations. Soft sounds have small, weak vibrations. Trapping the vibration make the sound louder. Trapping means that the smaller the distance, the more we trap the vibration. That's why. Volume is how loud or soft a sound is. We measure the volume of the sound with sound level meter. Our next chapter is 4.6, muffling sounds. The pages of this chapter are from 62 to 63. The words we need to know in this chapter are muffle, ear defender, silencers. Muffle is to make a sound less and less clear. Ear defenders are compliant with materials that muffle sound. They are worn over the ears. Silencers are equipment that make the sound quieter. The first way to muffle sounds is using ear defenders. Now, places like airplane and when people are using electronic drill, these sounds can be so loud that it damages the ear. So the workers who are using electronic drills, they are using ear defenders, and the people who are working in an airplane, like pilots, are using ear defenders. The next way is silencers. The sound of the engine in the car and motorcycles can be too loud. So we use silencers like these to muffle the sound. In the buildings, we also have carpets and curtains to muffle the sounds. Here, carpets and curtains, because they are soft material, they muffle the sounds really well. We also have materials between the walls in the building. So between our walls, we have materials that can muffle the sounds. So here we can see the stuff we put between the walls. They are kind of plastic, and this is a wood material type of thing they are using inside the walls to muffle the sounds. Which material muffles sound well? To see which materials muffle sounds the best, we need to go to this activity in the book in page 63. Okay, this is the activity. It's a bit blurry, but I'm assuming you all have your books opened in this page, so I don't think it's going to be a problem. Let's read the activity. Finding out which material muffles sound the best. Predict which material will muffle sound the best. Place the sound source in the box, pack one of the material around the sound source in the box, then place the lid on the box. Stand about 1 meter away from the box and listen to the sound. Is the sound loud or soft? Here we can see the activity. If you have a sound level meter, measure the sound volume and record it. Repeat the activity with other materials. Present your results in a table. The questions are, which material muffles sound the best? Why do you think so? Was your prediction correct? Is this investigation a fair test? Explain why or why not. Now, I'm going to show you the activity, but before I show you the activity, let us see if this investigation is a fair test. This experiment will not be a fair test if we use different boxes, different distance from the box, different layers over the source, and different volumes. But it will be a fair test if we use the same box, same distance from the box, and same layers over the source, also same volume for all the material. Now let's watch the experiment.
Yes, hello everybody. We are going to do an experiment again today. We're going to focus on activity 4.6, muffle sound. So what does it mean to muffle sound? It means actually to make the sound less clear and softer. So for example, if you have a boring or annoying brother or sister that keeps on talking and irritating you, usually you close your ears, and that is actually, you muffle the sound. But what we're going to test today is which type of material actually muffles sound the best. So, there are 4 things that we need to keep the same during this test to make sure this is a fair test. The first thing that we're going to use the same box every time. Okay? As well, when we measure or when we're going to listen to the sound, every time we're going to be 1 meter away. So, I've measured 1 meter from the box and made a line, so that I'm 100% sure the camera is 1 meter away every time. So, and then the next thing that we're going to use, I'm going to use the same cell phone so that I know exactly the volume is exactly the same. So my volume setting during this whole experiment needs to be exactly the same as well. So with those 4 things being the same, I know I'm going to get a fair test. Now there's a few things we're going to need, as you've already seen. Cell phone we need, box we need with a lid, measuring tape, and then we're going to need a t-shirt, we're going to need a towel, we're going to need some aluminum foil, a pillow, okay, and some plastic bags. So these are the 4 different things, more than 4 different things we're going to use to actually see which type of material muffles sound the best. So now, with all those things ready in action, now we need to find something that is irritating. So let's have a look if I might have a song that is irritating and that I want to muffle the sound. Do you know the song? Yeah, I don't like the song. I want to muffle this sound. Okay, but before we start, we need to have a control. So what are we going to do? We're going to play the music inside the box from the cell phone without a lid, so that we know what is the standard what we start with. Okay, so let's start with the first one. Lid off, in the box, and play. Okay, so that is the first one. So, I guess that sound was pretty clear and pretty loud. Now, actually the box is helping us to trap the sound a little bit and actually give the sound vibrations in one direction. So that might be the reason why it's a little bit louder. So, let's try the same, but now we're going to put on the lid. Okay. Now with the lid, does it muffle the sound? There's clearly a difference in the volume of this sound. So, the lid is quite good. Okay, but let's see other different types of material. Okay, so let's try plastic bags. So, 1 plastic bag, and I'm gonna put my phone in so long. Okay. And second plastic bag. So let's see if that is muffling the sound. A small difference. A small difference. Okay. Now, baby shark. Yeah. Now, next one. This is not working properly, so let's try aluminium foil. Not helping at all to muffle that sound. Okay, so let's try a next one. Let's try a t-shirt. Okay. Yes, wash. So I guess it's gonna work for me. Yes, there's a difference, but I think still the lid was actually the best muffler so far. Okay, let's try a towel and see how that will work. Okay. And towel baby. That's a big difference. It's not as clear, it's quite softer. That is a good one so far. That winner so far. So, let's see, the last one we're going to test is going to be the pillow. So, now, pillow, let's have a look. I think that is the best one. Clearly, it is not as clear. Clearly, it's quite softer. So, if you have a pillow, that's your best thing to muffle. Okay, to muffle the sound. So if you get excited, just scream at a pillow. If you think science is the best. Guys, this is an experiment and we've tested different types of material to see which one muffles sound the best. Clearly when we have a pillow, and what we've tested, that's the best one for now. Guys, thank you for joining, guys. I hope you had a great fun as I did. Cheers.
So as we saw in the video, the pillow muffled the sound the best. The pillow muffled the sound the best because it's softer. So the softer the material is, the better it muffles the sound. Again, this experiment is fair because this is the microphone. We are not moving the microphone at all, and this is the source of the sound. We are using a sound level meter for this one, and it shows through the laptop. This is the screen of the laptop that it shows the sound level meter. What we do is, what they did in this experiment is to each time cover the source of the sound with a material and see which material makes the sound the most quiet. The greater the negative number that's shown in the screen, it means the quieter the sound. So here we have the sound in open air, -30. This is open air. We have no cover on the source of the sound at all.
Bring it in. Let it down.
They used a common bath towel, soft. Again, the distance from the microphone does not change at all. The distance between the cover and the level of the sound does not change at all. We still put it on the lid of the box. See, we have a bigger negative number.
It sounded to me like it's doing much. Oh. Okay.
Okay, so the focus points in this chapter are: muffling sound is making the sounds less and less clear and more quiet. Some materials muffle sound well, some materials are not good at muffling sounds. The softer the material, the better it is to muffle the sounds. It is important for the experiments to be fair. You make a fair test by changing one factor at a time while keeping all the other materials the same.